Welcome to this trig lesson on finding the sine of a sum. Do you remember this picture from lesson 2? I took a screenshot. Sorry it's blurry. When the hypotenuse is 1, the opposite side equals the sine of the angle, and the adjacent side equals the cosine of the angle. We will use this result a few times in this lesson. In this lesson, we want to derive an identity for sine of a plus b. Let's draw two angles, A and B, and assume we know their sine values. We'll restrict our attention to acute angles, but it turns out the same result applies to all angles. Do you think we have enough information to find sine of a plus b? A guess would be sine A plus sine B, but that doesn't work. For example, when A and B both equal to 30 degrees, the left side gives us sine of 60, which is square root 3 over 2, but the right side gives us a half plus 1/2, and that's 1. So those aren't equal. How do we go about finding sine of a plus b? In math, we make sketches. We'll definitely need a right triangle, so let's drop a vertical line down. To make it easier, we'll assign the hypotenuse a length of 1. That means sine of a plus b equals the opposite side, the length of that dotted line. Now we know what to solve for. Keep thinking. We want to get sine A and sine B in there somehow, right? That means we have to construct more right triangles. We already see a right triangle containing angle A, but that one won't do us much good because we don't know any of its sides yet. So let's take care of angle B first. The obvious thing to do is to drop a vertical line from the highest point. There. Perfect. The hypotenuse of this triangle is 1. That should ring a bell. Let's pause for a moment, stare at the picture, and see whether we could add any information. Do you see that we just introduced two similar triangles? Also, we have two more sides to work with. Where are the similar triangles? There they are. Those opposite angles are equal. That means that pointy angle on the top also equals to angle A. How cool! Back to the original picture. That green triangle has hypotenuse 1. Perfect. That means the opposite side of B is sine B, and the adjacent side of B is cosine B. Wow, that's a lot of information. In fact, there is enough information here to calculate sine of a plus b already. However, this solution involves a lot of algebra and our favorite trig identity, sine squared plus cosine squared is 1. Those of you who love puzzles might like to try that later. Here, we are going to find a simpler solution. We have not made use of sine A yet. Where's the best place to draw a right triangle for angle A? There, because we already know the hypotenuse of this triangle. It's cosine B. That means we can find the other legs of this triangle. Let's clear up the clutter. How are we going to make use of sign A? Sign A enables us to solve for the dotted blue line. So if we draw that green line, it will break sine of A plus B into two segments, each of which equals a leg of a pink triangle with angle A. Isn't that surprising? The pink triangle on the top has hypotenuse sine B, whereas the pink triangle on the bottom has hypotenuse cosine B. Let's name our unknowns x and y. So sine of A plus B is going to be x plus y. For the pink triangle on top, we have cosine of A is equal to its adjacent side x divided by its hypotenuse sine B. So x equals cosine A times sine B. For the pink triangle on the bottom, we have sine of A is equal to its opposite side y divided by the hypotenuse cosine B. So y equals sine A times cosine B. Wow! Look what sine of A plus B turns out to be.
Amazing! That's beautiful. I can't believe it. How could it be nicer? It's so unexpected.
Okay, Chipmunk. Calm down. That was incredibly fun. Do you think you can derive cosine of A plus B by yourself? Use the same picture, because cosine of A plus B is the bottom piece. We'll do that one next time, okay? See you then. Bye.